Hi, and welcome to the fourth section of this course, A Game of Chess. In this section, we'll learn how to build a game of chess in TK-Enter. If you already know the basic rules of chess, you're ready to write this program. However, in case you do not know the rules, you should read them before you start programming this application. The key aspects that we want you to learn from this section include the following: learning how to structure a program in a model view controller architecture, learning how to tame complexity by implementing programs in a modular structure, taking a look at the versatility and power of the TK-Enter Canvas widget, learning the basic usage of Canvas coordinates, object IDs, and tags, learning the recommended error handling practices, learning how to extend Python's built-in data types, using object inheritance to code classes with similar attributes and behavior, using Python's built-in config parser module to store program preferences, getting acquainted with several Python modules that you will often use in a variety of application development projects. Now we will see the first video of Section 4, Structuring Our Program. The main goal of this section is to build a chess game. Our chess game will enforce all the standard rules that are applicable to a game of chess. Some advanced rules and features are left as an exercise for you. In its final form, our chess program will look like this. Module requirements for this section. We will not use any external third-party modules in this section. However, we will use several built-in modules of Python. To check whether all the required libraries are indeed provided by your Python distribution, type this command in your Python command line. This should be executed without an error message. If no errors are thrown back, you're ready to build the chess application. Let's get started. In this section, we decide an overall structure for our program. The development of large applications generally starts with recording the Software Requirement Specifications, SRS. This is generally followed by a graphical representation of constructs, such as the class, composition, inheritance, and the hiding of information using several modeling tools. These tools can be flowcharts, Unified Modeling Language, UML tools, data flow diagrams, Venn diagrams for database modeling, and so on. These tools are very useful when the problem domain is not very clear. However, if you have ever played the game of chess, you should be very well acquainted with the problem domain. Furthermore, our chess program can be classified as a medium-sized program spanning a few hundred lines of code. Therefore, let's bypass these visual tools and get to the actual program design. All of our previous projects have been structured as a single file. However, as programs grow in complexity, we need to break programs into modules and class structures. One of the key objectives of this chapter is to learn to write programs in the Model View Controller, MVC architecture. Some of the central aspects of the MVC architecture are: a model handles back-end data and logic. A view handles the front-end presentation. The model and view never interact directly. Whenever the view needs to access back-end data, it requests the controller to intervene with the model and fetch the required data. Given these aspects, let's create three files for our chess program: model.py, view.py, and controller.py. Now, let's create an empty model class, an empty view class, and a controller class in their respective files. Note that since the controller class needs to fetch data from the model class, we instantiated a new model class from within the controller class. This now provides us a way to fetch data from the model class as and when needed. Let's also add a separate file called exceptions.py. This will be our central place for the handling of all the errors and exceptions. Within this file, add the highlighted single line of code. We created a custom chess error class that was inherited from the standard exception class. This simple line of code now allows the chess error class and all of its children to raise errors, which can then be handled by using the try except block. All the new error classes that will be defined in our code from now on will derive from this chess error base class. With this boilerplate code out of the way, let's create another blank file called configurations.py. We will use this file to store all the constants and configurable values at one place. Let's define some constraints right away. To make these constant values available to all the files, let's import it in model.py, view.py, and controller.py folder. As per the tenets of the MVC architecture, the view class is never supposed to interact directly with the model class. it should always interact with the controller class, and the controller class is then responsible for the fetching of data from the model class. Accordingly, let's import the controller in the view class and the model in the controller class. Let's start by editing the view.py file to display a chessboard. Our goal for this iteration is to display the content in screen when view.py is run. Take a look at the code implementation in view.py. The _init_ method of the view class calls a method called create_chess_base, which is defined here. We will not reproduce the code responsible for the creation of the root window, the menu at the top, or the frame at the bottom. We have implemented similar widgets in previous sections. However, we will discuss the code that creates the chessboard. Nothing fancy here. Creating a canvas widget is similar to creating other widgets in tkinter. The canvas widget takes the width and height as two configurable options. Next, paint the canvas widget in alternating shades to form the chessboard. This is the description of the code. We use the canvas widget's create_rectangle method to draw alternating shades of squares to resemble a chessboard. The rectangles are drawn from point x1, y1, and they extend to x2, y2. These values correspond to two diagonally opposite corners of the rectangle, coordinates of the upper left and lower right edges. The x and y values are calculated by using a newly defined method called get_x_y coordinate, which performs simple mathematics depending on the dimensions of each square that was defined in pixel units earlier. The y value is calculated by first subtracting row from 7 row because the canvas widget measures the coordinates starting from the top left. The top left corner of the canvas has the coordinates 0, 0. The get_alternate_color method is a helper method that, not surprisingly, returns the alternate color. The tkinter canvas widget lets you draw a line, an oval, a rectangle, an arc, and polygon shapes at a given coordinate. You can also specify various configuration options such as fill, outline, width, and so on for each of these shapes. The canvas widget uses a coordinate system to specify the position of objects on the widget. Coordinates are measured in pixels. The top left corner of the canvas has the coordinates 0, 0. The objects drawn on the canvas widget are usually handled by assigning them an ID or a tag. We will see an example of this later in the chapter. If an object on the canvas widget is tagged to multiple tags, the options defined for tags at the top of the stack have a greater precedence. However, you can change the precedence of tags by using tag_raise name or tag_lower name. For a complete list of Canvas widget related options, refer to the interactive help for the Canvas widget using help tkinter.canvas in the command line. Next, let's bind the mouse click to the Canvas widget from the _init_ method of the view class. The bound method calls another method called get_clicked_row_column, and for now, it prints the result on the console. The get_clicked_row_column method is defined as. Now, if you run the code and click on different squares, it should output a message like this to the console. This completes our first iteration. In this iteration, we determined the broader file structure for the chess program. We created the model, view, and controller classes. We also decided to keep all the constants and configuration values in a separate file called configurations.py. We got the first taste of the Canvas widget. We created a blank canvas and then added square areas using the canvas.create_rectangle method to create a chessboard. Now, if you run 4.01 view.py, you will see an empty chessboard. You'll also find out that the File menu and the Edit menu drop-downs are non-functional. The About menu should show a standard message box widget. Before you proceed to the next section, you're encouraged to go and explore the code in our folder in its entirety. Nice! We've learned about structuring our program. In the next one, we'll learn about modeling the data structures.